In 1936, a huge collection of scientific documents and personal papers was put up for auction at Sotheby's in London.
The world's greatest scientist, Sir Isaac Newton, a veritable treasure trove of knowledge. Should we say starting at £2?
These papers had never been seen by the public, and a large number of them were bought by the famous British economist John Maynard Keynes.
Gone.
Many were written in secret code, and for 6 years, Keynes struggled to decipher them. He hoped they would reveal the private thoughts of the man who invented a new branch of math called calculus, figured out the composition of light, and gave us the laws of gravity and motion which govern the universe. The man who is considered the founder of modern science, Sir Isaac Newton.
Newton ushered in an age, the Newtonian age, and it was premised on the concept that everything, virtually in the universe, was amenable to scientific understanding.
Newton's work has a beauty and a simplicity and an elegance that makes it the greatest work of science ever done.
But what Keynes found shattered his image of Isaac Newton. For in these manuscripts, Keynes discovered an Isaac Newton unknown to the rest of the world. An Isaac Newton who seemed obsessed with religion and devoted to the occult.
He is known today as a sort of a high priest of the age of reason. But this is a misconstruction of Newton.
The modern interpretation of Newton is about as far as could possibly be from what Newton himself thought.
On the one hand, we can recognize him as a scientist, but on the other hand, he's pursuing an activity which we now label as a pseudoscience.
Now, scientists and historians are trying to reconcile the Isaac Newton they thought they knew with the Isaac Newton they're discovering in his private papers.
Our project now must be to see Newton the way that Newton was, rather than trying to see Newton the way we want him to be.
What are these mysterious documents revealing about one of the greatest scientists ever? Newton's Dark Secrets, right now on Nova.
Corporate funding for NOVA is provided by Google and by BP. Major funding for NOVA is provided by the Howard Hughes Medical Institute, serving society through biomedical research and science education, HHMI. Major funding for Newton's Dark Secrets is provided by the National Science Foundation, America's investment in the future. Additional funding is provided by American Playhouse. Major funding for NOVA is also provided by the Corporation for Public Broadcasting and by PBS viewers like you. Thank you.
In a library in Jerusalem lies an intensely curious document. It was written about 300 years ago, and only a handful of scholars have ever examined it. The author was arguably the most important scientist of all time, a genius who uncovered the laws of physics that govern the entire cosmos, Sir Isaac Newton. The subject? Newton's calculation of the date the Bible said the world as we know it would end in the Battle of Armageddon, the year 2060.
If this calculation were correct, then we are close to the time of the end. That's exactly what this sort of calculation would point to.
When this document came to public attention recently, it was headline news. But why was Isaac Newton making this dire prediction?
We find it surprising that Newton sounds like a televangelist talking about the end of time. We only find it shocking because we've made Newton something that he's not. We've made Newton in a rationalist, enlightened image. That's just not Newton.
What these manuscripts reveal is a very different Newton than most people conceive of. This is a Newton who is not a cold, calculating scientist. This is revealing Newton in all his glory, warts and all, if you will.
So who was the real Isaac Newton? On a small farm in rural England called Woolsthorpe, the conflicted life of Isaac Newton began in 1642. That same year, the astronomer Galileo had died, and his work was still sending shockwaves through Europe. Galileo had risked his freedom by challenging the ancient belief held by the Catholic Church that the sun moved around the earth. Based not on faith but observation, he confirmed the Earth was just one of several planets orbiting the sun. It was the dawn of the scientific revolution, an age when science and reason would redefine the world.
There was a sense of a whole new era. The very idea of having the empirical world answer our questions, that idea was taking hold in a way that had almost never done so before.
And from a young age, Newton was gripped by this new outlook. As a boy, he pored over a book called The Mysteries of Nature and Art, a manual for building mechanical contraptions and investigating the natural world.
He was preoccupied by the things that preoccupy physicists, by time and motion. So he made windmills, he made little boats, he flew kites that supposedly affrighted the locals. He tied candles to them and they were put up and they thought that they were comets.
But from the start, there was another side of Isaac Newton. His father died before he was born, and when he was just 3 years old, his mother remarried and moved away, leaving young Isaac behind with his grandparents. Newton later confessed to such rage that he wanted to burn his mother and stepfather in their house. And by the time he left home for Cambridge University, Newton had lived through 2 decades of violent political and social turmoil. A bloody civil war, the beheading of the king, and the restoration of the monarchy under Charles II in 1660. At Cambridge, Newton buried himself in his studies.
Truth is the offspring of silence and unbroken meditation.
He didn't go anywhere. I mean, he rarely traveled. He never went to the continent. He was that insular. I mean, he stayed in his rooms. He worked 7 days a week, 18 hours a day, and he pushed himself, drove himself. He had a library of his own that had about 1,600 or 1,800 volumes, but it was very much a world that came to him through printed matter or through manuscripts from others.
The decadent atmosphere of Cambridge was something the reclusive young Newton wanted no part of.
It was a time, particularly after the restoration of Charles II, it was a time of great fun and frolicking, and I think Newton would have been dismayed by many of the antics of his fellow students, drinking, going after bad young women in local villages.
To resist temptation, Newton drew up a plan that he'd stick to for the rest of his life.
The way to chastity is not to struggle directly with incontinent thoughts, but to avert ye thoughts by some employment, or by reading, or meditating on other things, or by converse. For he that's always thinking of chastity will be always thinking of women.
He's a very silent, thoughtful young man who, I suppose, looks as though he's utterly tedious from the outside. There's no evidence, I think, that anyone liked him at all, apart from his friend John Wickens.
John Wickens was another Cambridge student. He and Newton became roommates after both grew unhappy living with students who put pleasure before work.
They have a very peculiar relationship because Wickens is somebody who is of a higher status than Newton at Trinity and seems to have become Newton's amanuensis, i.e. his secretary, over the following 20 years. But they must have been very close. They lived in the same rooms for 20 years.
As a student, Newton devoured the latest scientific ideas. It was widely accepted by this time that the planets orbit the sun. But now the question was, how did the planets move? What held them in their orbits? The most popular theory came from the French philosopher René Descartes, who thought of the universe as a giant machine, like a clock. Descartes said everything, even the orbits of planets, could be explained simply as the physical interactions of parts of this machine. But Newton had trouble accepting this view of nature.
Newton's a very smart guy, and he became convinced that the only types of statements that are acceptable are ones which you could, to put it bluntly, test in the laboratory.
But just as Newton was probing the limits of Descartes, the plague struck England. Thousands died every week. The university closed, and Newton returned home to avoid infection. And it was here, in the apple orchard just outside the family home, that the legend of Isaac Newton was born.
The story, of course, is that he's lying in the garden there, and instead of thinking about girls, he's thinking about the moon and how it goes around the earth and so on. And an apple falls, and the story goes as bang, he suddenly has the idea that the same thing that's making the apple fall is what's holding the moon in its orbit.
Newton told this tale himself in his old age, claiming that with the fall of that apple, he realized that what held the planets in orbit was not a physical mechanism like Descartes' clockwork, but an invisible force he called gravity. And he was convinced that the force pulling apples down to Earth and keeping the moon in orbit around the Earth were one and the same. He stayed up late in the evening, calculating the strength of that force by the light of the fire. But when the numbers didn't quite work out, he put the idea aside. Or so the fable goes.
I doubt that an apple was what stimulated him to get the idea.
It's almost certainly an apocryphal story.
Yeah, I don't think it's even known whether it ever happened.
I'm extremely skeptical about the role of fruit in Newton's life.
But there is no doubt that the motion of objects like apples and the moon captivated Newton at this time. The Italian scientist Galileo had proved in a famous experiment on motion that all objects falling to Earth pick up speed or accelerate downwards at the same rate, regardless of their mass. And finding the average speed of a falling object was a straightforward process. For example, if you want to find the average speed of an apple falling from a tree, all you have to do is divide the distance the apple travels by the time it takes the apple to fall. But Newton was not satisfied with the average. What would be the speed of an apple which is constantly accelerating at every point along the way? What would the apple's velocity be halfway to the ground? To find out, you can measure the apple's average speed over smaller and smaller periods of time. The shorter the time interval, the closer you get to knowing the apple's speed at that moment. But to find its precise speed at a single instant, you have to reduce that time interval as close to zero as you can.
Newton invented a way to make that time interval infinitesimally small. What is infinitesimally small? That is smaller than any number that you can think of. It's not zero, but it is smaller than any number that you can think of.
For the first time, it was possible to calculate quantities that are constantly changing, like the speed of a falling apple at any particular moment, or how a planet's position changes over time. With this technique, Newton invented an entirely new branch of math called calculus.
And that changed all of science, of course. The whole way of looking at the world changed because of calculus, yeah.
Calculus was a quantitative understanding of the way things change. Not just velocity, but in physics, in chemistry, even in populations. How fast is a population changing over time? This mathematical framework becomes the language in which modern science is formulated.
Today, calculus shows up everywhere, from analyzing the stock market to modeling global climate change.
By the time he was 22 years of age, working on the calculus at Woolsthorpe, he was the greatest mathematician the world had ever seen, and yet no one knew. Only Newton knew, and it was his secret.
This was a guy who adored computation of every kind. Among the things that you can see if you open his manuscripts, for instance, is there are places where you'll find he's calculated logarithms out to 50 places and things like that. Not because he needed it, but because he liked doing it. I mean, it was a pleasure to him to do that sort of thing.
And if that weren't enough, Newton overturned accepted wisdom about how colors are produced, performing an experiment on himself with a large needle, or bodkin.
I took a bodkin and put it between my eye and the bone, as near to the back side of my eye as I could. And pressing my eye with the end of it, so as to make the curvature in my eye, there appeared several white, dark, and colored circles.
Fortunately, Newton found a safer way to investigate light and color, using a prism. From Aristotle to Descartes, scientists thought sunlight, or white light, was pure. Colors were produced by physically modifying white light, which they believed passing it through a prism did. But Newton decided to see for himself. Sending sunlight through a prism, he produced the spectrum of colors. And then he went one step further. He sent the red ray of light through a second prism. Instead of making a new color, it remained red. Newton concluded that white light is not pure, but a combination of all the colors of the rainbow.
He thought of the prism actually as a separator of the objects that are all in the original light. This was very hard for almost everybody to swallow, because it meant that when you're looking at white light, you're looking at something which has all the colors already in it. This seemed completely counterintuitive, and indeed, frankly, it's counterintuitive to most people today.
Only 25 years old, Newton had made some of the most stunning breakthroughs in the history of science. But he kept them almost entirely to himself, just as he had done with calculus. After the plague subsided, he returned to Cambridge, where he worked his way up to an appointment as the Lucasian Professor of Mathematics, the position held by Stephen Hawking today. Newton became known for his prematurely white hair and for his long-winded lectures on light.
That belongs to refractions, tacitly founding their demonstration on a certain physical hypothesis not well established. I judge it will not be unacceptable if I bring the principles of science to a more strict examination.
The introverted Newton had little time for students, and they had little interest in him. Years later, one of Newton's laboratory assistants would recall,
"So few went to him, and fewer that understood him, that oftentimes he did, in a manner, for want of hearers, read to the walls."
But Newton's study of light was about to start a revolution. 50 years earlier, Galileo had built one of the first telescopes. It used glass lenses to gather light from distant objects and focus it for the observer. But this kind of